AWS CloudWatch Unveiled, your guide to monitoring, alarming, and observability. Chapter 1, Navigating the Cloud, the unspoken need for monitoring. Imagine you're managing a vast, sprawling operation, perhaps a massive factory, but with one critical difference. All the machinery, every conveyor belt, every robotic arm is housed inside impenetrable, opaque boxes. You can hear faint hums and whirs, you know products are being manufactured, but you can't see the inner workings. You can't physically inspect a machine or even walk through the factory floor to check if everything is running smoothly. This is, in essence, the modern cloud computing environment. The promise of the cloud is immense: unparalleled scalability, cost-effectiveness, and agility. You can launch hundreds of servers in minutes, deploy complex applications with a few clicks, and scale resources up or down almost instantly to meet demand. This elasticity is revolutionary, but it also introduces a new challenge. In traditional on-premises data centers, you could walk up to a server rack, observe the blinking lights, check cable connections, or visually inspect a failing hard drive. Your resources were tangible, their health was often apparent. In the cloud, your infrastructure is typically managed by a service provider like Amazon Web Services, AWS. Your servers, databases, and network components are abstract representations in a powerful, distributed infrastructure. They are invisible, living somewhere in a vast global network of data centers. While this abstraction simplifies management and enhances flexibility, it also means you can't physically lay eyes on them. So, how do you know if your applications are running efficiently? How do you detect if a server is overloaded, a database is experiencing high latency, or if a critical component has simply stopped responding? This is where the unspoken, yet paramount, need for monitoring emerges. Simply put, monitoring is the practice of collecting and analyzing data about the operation of your systems and applications. It's about getting answers to fundamental questions like, is my website available? Are my servers overloaded? Or, why did that transaction fail? For many years, monitoring in the cloud was largely reactive. You'd get a call from a customer complaining their service was down, and then you'd scramble to investigate. But in the dynamic world of AWS, where resources can scale, change, and sometimes even fail without direct human intervention, reactive monitoring is a recipe for disaster. Downtime translates directly into lost revenue, frustrated customers, and damage to your reputation. The focus has shifted from simply knowing if something is down to understanding why it might be slowing down, who is being affected, and how to prevent it from happening again. This evolution has led to the broader concept of observability. Observability goes beyond just showing you performance metrics. It's about ensuring you have enough insights into your systems to understand their internal state merely by looking at their external output. Think of it as being able to infer the exact internal condition of a complex machine just by watching its dials, listening to its sounds, and examining its exhaust. It's about understanding the complex interplay between different components and quickly identifying the root cause of issues, even in highly distributed and constantly changing environments. Enter AWS CloudWatch. CloudWatch is Amazon's comprehensive monitoring and observability service built specifically for the cloud. It's the central nervous system, the command center, the control panel for your AWS resources, and the applications you run on AWS. It acts as your eyes and ears, tirelessly collecting operational data in three fundamental forms: metrics, logs, and events. Imagine our factory again, but this time, CloudWatch is giving you crucial data points right at your fingertips. Instead of just a hum from the black boxes, you're getting gauges and readings, metrics. How hot is the machinery? How fast is it producing? What's the stress level on its components? Detailed logbooks, logs. Every internal conversation, every error message, every step of the process is meticulously recorded in detailed reports. Urgent notifications, events. An alarm goes off when a machine's temperature hits a critical level, or a notification tells you a specific part needs maintenance. CloudWatch doesn't just collect this data, it empowers you to act on it. You can visualize trends on customizable dashboards, set up alarms to proactively notify you of problems, and even automate responses to specific conditions. ensuring your applications remain healthy, performant, and secure. It offers the ability to observe, alarm, and automate responses to changes in your AWS infrastructure and applications. Consider a real-world scenario. A rapidly growing online retail business, let's call them CloudCloth, launched their new website on Oz. Initially, everything seemed fine. They were delighted by the ease of deploying their services. However, as the busy holiday shopping season approached, they started noticing intermittent slowdowns. Their customers experienced frustrating delays, sometimes even timeouts, which directly impacted sales. Because their focus had been solely on deployment, they hadn't yet implemented a robust monitoring strategy. They had no idea why their site was sputtering. During the crucial Black Friday sale, their systems became overwhelmed. Customer complaints flooded social media, and sales plummeted. They eventually discovered, through a frantic manual investigation, that a specific database component was overloaded due to an unexpected surge in traffic. By then, significant damage was done. After this painful experience, CloudCloth turned to CloudWatch. They began collecting metrics on their website's load balancer, their server's CPU utilization, and their database's connection count. They started sending their applications error messages to CloudWatch logs. They even set up alarms to notify their team if critical thresholds were crossed. Over time, they built dashboards that gave them an immediate snapshot of their entire system's health. Now they could see the problem before it became a crisis. If database connections spiked, CloudWatch would alert them, allowing them to scale resources before customers were impacted. They moved from reactive damage control to proactive system management. This journey from reactive to proactive, from basic monitoring to comprehensive observability, is what CloudWatch enables. It's not just a tool, it's a fundamental pillar for operating successfully in the cloud. As we delve deeper into this book, we will explore precisely how CloudWatch collects, analyzes, and helps you act upon the vital data that ensures your cloud applications are always available, performing optimally, and delivering consistent value to your users. We'll begin by understanding the very building blocks, metrics, logs, and events. Chapter 2, The Foundation of Understanding, Metrics, Logs, and Events. In the previous chapter, we established that navigating the ethereal landscape of cloud computing demands robust visibility. AWS CloudWatch provides this visibility by acting as a central intelligence hub, continuously gathering critical information about your resources and applications. This information comes in three fundamental forms: metrics, logs, and events. Understanding these three pillars is crucial, as they form the bedrock of all monitoring, alarming, and automation you'll implement with CloudWatch. Think of it like this. If you were monitoring the health of a complex organism, you wouldn't rely on just one type of information. You'd want its vital signs, metrics, a detailed record of its activities and internal processes, logs, and immediate alerts about significant changes or incidents, events. CloudWatch brings these three perspectives together to give you a comprehensive picture of your cloud environment. Metrics, the vital signs of your cloud. Let's start with metrics. In the simplest terms, a metric is a numerical time series data point. It's a quantitative measurement of a specific aspect of your resource or application, recorded over time. Imagine them as the vital signs of your cloud infrastructure. CPU utilization. How busy is your server's processor? Network in out. How much data is flowing to and from your network interfaces? Database connections. How many clients are currently connected to your database? Request count. How many incoming requests is your web application receiving per minute? Latency. How long does it take for your application to respond to a request? Error rate. What percentage of requests are resulting in errors? CloudWatch automatically collects many standard metrics from various AWS services, like EC2 instances, S3 buckets, RDS databases, and Lambda functions, without any configuration from your side. These are called standard metrics. You can also publish your own custom metrics from your applications or on-premises servers, allowing you to monitor anything you can measure. Every metric in CloudWatch is defined by its name, a unit like bytes, seconds, percent, and one or more dimensions. Dimensions are key-value pairs that help describe and filter a metric. For example, CPU utilization could have a dimension of instancid to specify which particular server you're monitoring, or load balancer and availability zone to pinpoint specific load balancer performance. Dimensions add crucial context, allowing you to slice and dice your data precisely. Analogy: consider your car's dashboard. The speedometer, fuel gauge, and engine temperature gauge are all displaying metrics. They are numerical readings that tell you the current state of a specific aspect of your car: speed, fuel level, engine heat. They are quick, quantifiable indicators. Logs, the detailed journal entries. Next, we have logs. While metrics offer a high-level numerical overview, logs provide the granular, textual details behind the numbers. Logs are streams of records that capture discrete events or activities occurring within your systems. Think of them as the doctor's notes or daily journal entries for your applications and infrastructure components. They explain what happened when it happened and why it happened. Examples of log data include application error messages, database connection failed, invalid user login, web server access requests. Every time someone visits your website, details like their IP address, the page they requested, and the time are logged. System messages, operating system startup messages, security warnings, or configuration changes. Database query logs, records of every command sent to your database. CloudWatch doesn't just store these logs. It offers a powerful service called CloudWatch Logs that centralizes, stores, and allows you to search and analyze them. Instead of sifting through log files on individual servers, you can send logs from various sources: EC2 instances, Lambda functions, containers, custom applications, directly to CloudWatch logs. They are then organized into log groups, e.g., all logs from a specific application, and log streams, e.g., logs from a single server instance or Lambda invocation within that group. CloudWatch Logs Insights, a powerful query language, allows you to ask complex questions of your log data, extracting patterns, counting occurrences, or even charting trends directly from your raw text. This transforms vast amounts of log data into actionable insights. Analogy: the car's diagnostic computer system generates logs. When something goes wrong, it doesn't just show a generic check engine light, a metric. It writes detailed error codes and messages. Oxygen sensor malfunction, bank 1, sensor 2, at 14:32:5 GMT5 on October 26th, providing the granular data needed for troubleshooting. Events, the real-time triggers. Finally, we arrive at events. An event is a sudden, discrete, real-time notification about a change in your OS environment or an application. Unlike metrics, which are continuous measurements, or logs, which are historical records, events are notifications of something happening right now. They are the urgent calls that trigger immediate responses. Events can originate from a wide array of sources. AWS service events, an Amazon EC2 instance changing its state from running to stopped, an object being uploaded to an S3 bucket, a new user being created in IAM. Scheduled events, a time-based schedule you define, e.g., every day at 3 a.m. Custom application events, your own applications can publish custom events to indicate specific occurrences, like a new order being placed or a critical processing step being completed. SaaS partner events, events from integrated third-party software as a service, SaaS, applications. The service that primarily handles these events is Amazon Event Bridge, which was formerly known as CloudWatch Events, highlighting its central role in CloudWatch's ecosystem. EventBridge acts as a serverless event bus, intelligently routing events from various sources to different targets. You define rules based on specific event patterns, e.g., anytime an S3 object is created in this bucket, or schedules. When an event matches a rule, EventBridge sends it to specified targets. These targets can be other OS services, such as a Lambda function to process the event data, an SNS topic to send out a notification via email or SMS, an EC2 instance to trigger an action on a server, an AWS step function's state machine to kick off a complex workflow. Analogy: your car's warning lights or navigation system. A low tire pressure, light flashing, an event triggers an immediate response from you. Or the navigation system announcing turn left in 200 feet. A scheduled event at a specific location triggers your turning action. These are real-time, singular occurrences that demand an action, bringing it all together. Metrics, logs, and events are distinct but highly complementary. Metrics tell you what is happening at a high level, e.g., CPU utilization is high. Logs tell you why it's happening, providing the detailed context, e.g., these specific error messages are flooding the logs, causing the CPU spike. Events enable reactions to crucial happenings, e.g., the server just reported a critical error, triggering an automation script to restart it. By leveraging these three foundational data types, coupled with CloudWatch's powerful capabilities to process, analyze, and act upon them, you gain unparalleled insight into your cloud operations. In the coming chapters, we will dive into how you can use each of these pillars to monitor, alarm, visualize, and automate responses, transforming them from raw data into actionable intelligence. Without this basic understanding of metrics, logs, and events, effective cloud monitoring would be impossible. Chapter 3: Proactive Protections, Setting Up Alarms and Notifications. Imagine a security guard whose job is to keep an eye on a building. They might look at a gauge showing the number of people inside, a metric, or review a log of who entered and exited logs. But what's truly proactive is when a motion sensor triggers an immediate alert, or a smoke detector blares an alarm the moment smoke is detected. This immediate, automated response to a critical condition is the essence of CloudWatch alarms. In the digital world, waiting for a user to report that your website is down or your application is slow is a reactive approach that can lead to significant business losses and customer dissatisfaction. CloudWatch alarms are your frontline defense, constantly monitoring your metrics and notifying you, or even taking automated actions the moment something goes awry. They turn passive data observation into proactive problem prevention. What are CloudWatch alarms? A CloudWatch alarm is a mechanism that continuously watches a single CloudWatch metric over a specified period. When the value of that metric breaches a predefined threshold for a certain duration, the alarm changes its state, and the state change can trigger one or more actions. Every CloudWatch alarm has three fundamental states. Okay, the metric is within the acceptable range. Everything is operating normally. Alarm, the metric has violated the defined threshold. Something is wrong or is about to be wrong and requires attention. INSUFFICINTDATA. The alarm doesn't have enough data to determine the state. This can happen, for instance, if the metric stops being reported. The power of alarms lies in their ability to transition between these states and, crucially, to initiate actions when a transition occurs. How do alarms work? The core components. Setting up an alarm involves defining several key parameters. Metric selection. You choose the specific metric you want to monitor. This could be a standard OS metric, like CPU utilization for an EC2 instance, network receive throughput for a load balancer, or database connections for an RDS instance, or a custom metric you've published. Threshold, this is the critical line in the sand. You define a value that, if crossed, indicates a problem. For example, you might set a threshold for CPU utilization to be 80%. Statistic. Since metrics are time series data, you need to tell the alarm how to evaluate the data points within a given period. Common statistics include average, the average value of the metric over the period. Sum, the total value over the period, useful for counts like invocations. Minimum, the lowest value over the period. Maximum, the highest value over the period. Sample count, the number of data points over the period. Period. This is the duration over which the metric is evaluated. For example, a 5-minute period means the alarm will calculate the chosen statistic, e.g., average CPU, every 5 minutes. Choosing the right period is important. Too short, and you might get false alarms. Too long, and you might detect issues too late. Data points to alarm. This determines how many consecutive periods the metric must be in violation of the threshold before the alarm state changes to alarm. For example, 2 out of 3 data points means that within a rolling window of 3 evaluation periods, at least 2 of them must have breached the threshold. This helps prevent transient spikes from triggering false alarms. Example scenario: you want to know if your web server's CPU is consistently high. You could create an alarm that monitors the CPU utilization metric for your EC2 instance. Metric: CPU utilization. Statistic: average. Threshold: 80%. Period: 5 minutes. Data points to alarm: 2 out of 2, meaning the average CPU must be over 80% for 2 consecutive 5-minute periods. Taking action: notification and automation. The real power of CloudWatch alarms comes from the actions they can trigger when their state changes. These actions fall into several categories. Notifications via SNS. This is the most common and often the first action you'll configure. When an alarm moves into an alarm state, or back to OK, or INSUFFICANTDATA, it can publish a message to an Amazon Simple Notification Service, SNS topic. SNS can then deliver this message to various endpoints, including email addresses, sending an email to your operations team. SMS messages, texting a duty engineer. PagerDuty /Slack/Microsoft Teams, integrating with third-party incident management or collaboration tools. Lambda functions, triggering custom logic based on the notification. Auto-scaling actions. For EC2 instances, alarms can directly trigger auto-scaling policies. This is incredibly powerful for maintaining application performance. If an alarm indicates high CPU utilization or network traffic, it can tell auto-scaling to add more instances to handle the load. Conversely, if traffic drops, an alarm could trigger scaling down to save costs. EC2 actions. Alarms can directly perform actions on specific EC2 instances, such as stop, shutting down an instance; terminate, permanently deleting an instance; reboot, restarting an instance; recover, automatically recovering impaired instances by rebooting them on healthy underlying hardware, useful for underlying hardware degradation. Systems Manager actions. Connect alarms to AWS Systems Manager to automatically create Ops Center incidents for centralized operational data, or execute Systems Manager automation documents for automated runbooks. Analogy: the smoke detector doesn't just buzz, it also calls the fire department and unlocks the doors. Similarly, a CloudWatch alarm can notify your team via email buzzing and separately trigger an auto-scaling event to add more capacity, call the fire department, or even restart a problematic server, unlocking doors to allow evacuation and reset. Importance of proactive alarms. Implementing a robust alarm strategy is fundamental to maintaining a healthy and resilient cloud environment. Reduced downtime. Identify and address issues before they lead to full outages. Improved performance. Ensure your applications maintain optimal speed and responsiveness by reacting to performance degradations. Faster root cause analysis. Alarms pinpoint where and when a problem began, speeding up investigation. Cost optimization. Alarms can signal when resources are underutilized, allowing for scaling down and cost savings. Enhanced customer experience. Proactive problem resolution translates directly into a more reliable and satisfying experience for your users. However, beware of alarm fatigue. Too many alarms, or alarms with poorly set thresholds, can lead to your team ignoring critical alerts amidst a flood of noise. It's crucial to set meaningful thresholds that genuinely indicate a problem, and to refine your alarms over time as you understand your system's baseline behavior. Setting up alarms is often the first step in building a resilient cloud infrastructure. In the next chapter, we'll explore how to visually represent the metrics that drive these alarms, allowing you to quickly grasp the operational health of your entire system at a glance. Chapter 4, Your Cloud Command Center, Building Effective Dashboards. In the previous chapter, we explored the critical role of CloudWatch alarms as your proactive guardians, notifying you of potential issues the moment they arise. While alarms are essential for immediate alerts, they don't provide the full picture. Imagine managing a large, complex factory. You need alarms for critical failures, but you also need a central control room, a comprehensive visual display to monitor the overall health of each production line, identify emerging trends, and correlate data from different departments. This central control room in CloudWatch is the dashboard. CloudWatch dashboards allow you to create customizable home pages in the AWS Management Console that display a consolidated, visual overview of your cloud resources and applications. They transform raw metrics and complex log data into easily digestible graphs, charts, and single-value displays. They are your operational command center, designed for quick status checks, trend analysis, and collaborative troubleshooting. The power of visualization. Humans are inherently visual creatures. While lists of numbers or endless log streams can be overwhelming, a well-designed graph can instantly communicate change, identify anomalies, and highlight relationships between disparate data points. Dashboards capitalize on this by providing at-a-glance operational awareness. Quickly determine the overall health of your application or infrastructure without sifting through multiple screens or services. Trend identification. Spot patterns over time. Is CPU utilization always high on Tuesdays? Are error rates gradually increasing? Correlation. See how different metrics relate to each other. Does a spike in network traffic correlate with a drop in application response time? Faster troubleshooting. When an alarm fires, a dashboard can be your first stop to visually confirm the issue and identify contributing factors. Common operating picture. Provide a shared view for your team, fostering better collaboration and consistent understanding of system performance. Building your dashboard. Widgets galore. CloudWatch dashboards are highly customizable, built using various types of widgets, each designed to present data in a specific way. Line graphs, metric widgets. The most common widget, brilliant for showing how a metric changes over time. You can combine multiple metrics on a single graph, allowing for easy comparison and correlation, e.g., EC2 CPU utilization alongside network traffic. You can display different statistics, average, sum, max, min, and change time ranges, from 1 hour to 3 months or even custom ranges. Stacked area graphs, ideal for visualizing contributions to a total, such as breaking down network traffic by instance or showing throughput from different components combining to create a total. Number widgets, simple, clear, and impactful. These display the current or aggregate value of a single metric as a large number, perfect for critical indicators like live users, error count, or estimated cost. Log query widgets, one of the most powerful integrations. These allow you to embed the results of CloudWatch logs, insights, queries directly into your dashboard. You can show the most frequent error messages, the top IP addresses generating requests, or recent critical events, bringing the detailed context of your logs right alongside your metrics. Alarm status widgets display the current state, OK, alarm, insufficient data of one or more CloudWatch alarms. This is excellent for seeing the status of your critical alerts at a glance. Text widgets, simple markdown-enabled text areas. Use these for adding explanations, helpful links, team contacts, or documentation references directly onto your dashboard, making it more informative and self-explanatory. Practical example, imagine setting up a dashboard for your e-commerce website. You might include a line graph showing the average latency of your Elastic Load Balancer, ELB, over the last 24 hours. Another line graph displaying the average CPU utilization across your EC2 instances. A number widget for the current number of users. A custom metric you've published. An alarm status widget for your high latency and server unhealthy alarms. A log query widget showing the count of 5xx errors from your web server logs in the past hour. A text widget with a link to your incident response playbook. Beyond basic dashboards, features for enhanced utility. CloudWatch dashboards offer capabilities that extend their utility. Automatic dashboards. Many AWS services automatically create dashboards in CloudWatch for their core metrics. While these are a great starting point, custom dashboards offer far more flexibility and cross-service correlation. Sharing. You can share dashboards with other Oz users in your account. This is invaluable for collaboration between teams, allowing them to view common performance metrics. You can even generate a public URL for a read-only snapshot of a dashboard. which can be useful for sharing high-level overviews with non-AWS console users, with appropriate security considerations. Time range selection. Quickly change the time window of all widgets on a dashboard, e.g., view metrics for the last hour, day, week, or a custom range, to observe short-term fluctuations or long-term trends. Cross-account and cross-region dashboards. For larger organizations, you can create dashboards that pull metrics from different AWS accounts and regions into a unified view, providing a truly global operational command center. This requires specific configurations that consolidate data from multiple sources. Designing effective dashboards. Creating a useful dashboard is as much an art as it is a science. Here are some tips for effective dashboard design. Define your audience and purpose. Who is this dashboard for? Developers, operations, management? What critical questions should it answer? A developer might need granular metrics, while a manager needs high-level business KPIs. Focus on critical metrics. Don't clutter your dashboard with every available metric. Prioritize the key performance indicators, KPIs, and operational health metrics that truly matter. Group related information. Place widgets that show related metrics or logs close together to facilitate correlation. Use clear titles and labels. Ensure every widget has a descriptive title and axes are clearly labeled. Less can be more. Overload can lead to alarm fatigue. A few focused dashboards are often more effective than one massive, overwhelming one. Iterate and refine. Dashboards are not static. As your application evolves or new operational patterns emerge, refine your dashboards to meet changing needs. Get feedback from your team. Dashboards are the eyes of your operational intelligence. They provide the context, the visual clues, and the historical data necessary to understand the narrative behind your alerts. Combined with the proactive nature of CloudWatch alarms, they equip you with the insights needed to maintain and optimize your cloud applications. In the next chapter, we will delve deeper into the raw textual data, your logs, and explore how CloudWatch helps you unearth actionable insights from these detailed journals. Chapter 5. Unearthing Insights. Deep diving into your logs. So far, we've explored metrics, the numerical vital signs of your systems, and alarms and dashboards, which provide immediate alerts and visual summaries. But sometimes, when an alarm fires or a dashboard graph dips unexpectedly, you need to go beyond the numbers. You need to understand why something is happening. What specific error occurred? Which user was affected? What sequence of events led to the problem? This is where logs come into play. Logs are the detailed journals of your applications and infrastructure, capturing discrete events, errors, access attempts, and operational messages. They contain the granular, textual information that provides crucial context and enables deep forensic analysis. Without them, troubleshooting complex issues in distributed cloud environments would be like trying to solve a mystery without any clues. In the past, managing logs meant logging into individual servers, piecing together information from various log files, and wrestling with tools like grep or tail. In the dynamic, ephemeral world of the cloud, where servers can spin up and down in minutes, and your applications might consist of dozens of microservices, this traditional approach is simply impractical. Enter CloudWatch Logs. CloudWatch Logs provides a centralized, scalable, and highly available service for ingesting, storing, and accessing all your log data from various sources across your AWS environment. It transforms log management from a fragmented chore into a streamlined, powerful diagnostic capability. Centralized logging, your single source of truth. CloudWatch Logs works by collecting log events from different sources and organizing them logically. Log events, each individual entry in a log stream, e.g., an error message and access record. Log streams, a sequence of log events from a single source, e.g., a specific EC2 instance, a particular Lambda function invocation, or a specific process within a container. Log groups, collections of log streams that share the same retention, monitoring, and access control settings. Often, a log group corresponds to an application, a service, or a logical grouping of resources, e.g., AWS Lambda My Web App, /var/log/ Apache 2/accesslog, /vpc/flowlogs. AWS services like Lambda, Fargate, Amazon RDS, API Gateway, and many others can automatically send their logs directly to CloudWatch Logs. For EC2 instances and on-premises servers, you can use the CloudWatch agent, a lightweight piece of software that collects logs and custom metrics, and securely streams them to CloudWatch Logs. This central repository means you no longer have to manually access individual machines to retrieve log data. Unearthing insights with CloudWatch Logs Insights. Collecting logs is one thing, making sense of them is another. This is where CloudWatch Logs Insights shines. Logs Insights provides a powerful and intuitive query language specifically designed for interactive analysis of your log data. It allows you to quickly search, filter, parse, and visualize your logs, turning raw text into actionable insights. Think of Logs Insights as a powerful magnifying glass and a sophisticated data analysis suite combined. You can use it to find specific error messages. Show me all log entries containing error or timeout in the last hour. Count occurrences. How many times did a specific HTTP status code, e.g., 500, appear? Identify unique patterns. What are the top 10 unique IP addresses accessing my API? Calculate performance metrics. What is the average duration of my Lambda function invocations that completed successfully? Parse unstructured logs. Extract specific fields, like request IDs, user IDs, or latency values from complex log lines, even if they don't follow a strict format. Visualize query results. Generate bar charts, line graphs, or pie charts directly from your query results, allowing for quick visual understanding. How it works. You select a log group or multiple log groups, type your query in the Logs Insights console, and execute it. The query typically involves filter, to narrow down log events based on keywords or field values. Parse, to extract specific data fields from log messages. Stats, to perform aggregations like count, sum, AVG, min, max, or percentile. Sort, to order the results. Limit, to restrict the number of results. Display, to select which fields to show in the output. Example query, to find how many 500-level errors occurred in a specific web applications. Access logs, and group them by the API path. Filter at message like /500. Parse at message as a pippath status code. Stats count as error count by a pippath. Sort error count desk. Limit 10. This query would first filter for messages containing 500. Then extract the pippath and status code. Count the occurrences of each pippath that had a 500 error, sort them by the highest count, and show the top 10. Metric filters. Bridging logs and metrics. Sometimes, a specific pattern in your logs is so critical that you want to monitor it like a metric and potentially trigger an alarm. Metric filters allow you to do exactly this. A metric filter defines a pattern to look for in your log data. When the pattern is matched, CloudWatch increments a custom metric. For instance, you could create a metric filter that looks for the string out-of-memory error in your application logs. Every time this string appears, a custom metric called out-of-memory errors count is incremented. You can then create a CloudWatch alarm on this custom metric to notify you whenever the count exceeds a certain threshold, even if those errors were just one type of warning among millions of log entries. Importance of deep log analysis. Effective log analysis is crucial for troubleshooting and root cause analysis. Quickly identify the exact error message, stack trace, or user interaction that led to a problem. Security auditing. Monitor for unauthorized access attempts, suspicious activities, or policy violations recorded in your logs. Performance tuning. Discover slow database queries, inefficient code paths, or bottlenecks by analyzing log timestamps and execution details. Compliance. Maintain a historical record of system activities for audit and compliance purposes. Understanding user behavior. Analyze access logs to understand traffic patterns and popular features. In essence, CloudWatch Logs, particularly with the power of Logs Insights, transforms your scattered, overwhelming log data into a highly organized, searchable, and insightful database. It enables your teams to rapidly diagnose issues, understand system behavior, and improve the reliability and performance of your cloud applications. While metrics give you the what, Logs diving in with Logs Insights provides the essential why and how. The next chapter will build on this, showing how events, a third data pillar, allow for automated reactions to changes within your environment. Chapter 6, Automated Responses, Harnessing CloudWatch Events Event Bridge. We've now covered metrics, logs, and alarms, the pillars of understanding and protection. Metrics tell you what is happening, logs give you the why, and alarms tell you when something needs attention. But what if you could automatically react to these changes or specific occurrences without human intervention? What if you could build your cloud environment to be self-healing, self-optimizing, and intensely responsive? This is the domain of events and the powerful service that orchestrates them. Amazon Event Bridge, formerly known as CloudWatch Events. Think of your cloud environment as a bustling city. Metrics are the traffic reports, showing congestion or smooth flow. Logs are the building plans, revealing every pipe and wire system. Alarms are the emergency services, rushing to an accident. But Event Bridge is the city's intelligent nervous system, a sophisticated postal service, dispatch hub, and scheduling agency rolled into one. It's constantly listening for various messages or signals, events, from every corner of the city, and then automatically routes those signals to the right recipient for a specific action. What is Event Bridge and why is it essential? Event Bridge is a serverless event bus service that makes it easy to connect your applications with data from your own applications, SaaS applications, and various AWS services. It enables you to build scalable, loosely coupled, and responsive event-driven architectures. Instead of applications constantly checking for status changes, polling, Event Bridge allows them to simply react to events as they occur. This paradigm shift from polling to event-driven architectures offers significant benefits. Reduced complexity. Services only need to know how to emit or consume events, not how to directly interact with every other service. Increased agility. You can easily add new functionality or change existing logic by simply adding new event consumers without modifying existing codebases. Real-time responsiveness. Actions are triggered immediately when an event occurs, enabling highly reactive systems. Improved scalability. Event Bridge handles the routing and delivery of events, allowing your services to scale independently. The anatomy of an event-driven system. Event Bridge operates on a simple but powerful principle. Event source, something happens that generates an event. Event bus, a central point where events are sent. Event Bridge provides a default bus, but you can create custom ones. Event rules, you define rules that match specific patterns within the incoming events. Targets. When a rule matches an event, Event Bridge sends the event to one or more designated targets, which then perform specific actions. Let's look at the different types of event sources. AWS services. Over 200 AWS services automatically publish events to Event Bridge. These are fundamental changes in your AWS environment. Examples include: an EC2 instance changes its state, e.g., from pending to running or running to stopped. An object is successfully uploaded or deleted from an S3 bucket. A new user is created in AWS Identity and Access Management, IAM, a DynamoDB table scaling action. Errors detected by AWS Health Dashboard for service disruptions. Custom applications. Your own applications can publish custom events to Event Bridge. This allows you to build event-driven workflows based on your business logic, e.g., user signed up, order processed, login failed. SaaS applications. Event Bridge has direct integrations with popular third-party software as a service. SaaS, applications like Salesforce, Zendesk, PagerDuty, and more. This allows you to unify events from your cloud infrastructure and your critical business applications. Scheduled events. You can define rules based on a schedule, using cron expressions or fixed rates. This is ideal for triggering routine tasks, such as daily reports, data backups, or periodic health checks. Defining event rules and targets. The magic happens with event rules. An event rule consists of two main parts: event pattern. This is the filter that determines which events the rule will capture. You define specific JSON patterns that are matched against the incoming event structure. You can be as broad or as specific as needed. Broad example: source, OSEC2, detail type, EC2 instance state change notification, matches any state change for any EC2 instance. Specific example: source, OSAC2, detail type, EC2 instance state change notification, detail, instancid, I0123456789 updef0, state, stopped, it only matches when a specific instance stops. Targets, once an event matches a rule, it is sent to one or more targets to perform an action. Event Bridge supports numerous OS services as targets, including Lambda functions, the most common target, allowing you to execute custom code in response to an event. SNS topics, to send notifications, email, SMS, push messages. SQS queues, to ingest events for later processing by other systems. ECS tasks, to run containers. Step functions, to initiate complex, multi-step workflows. Systems Manager automation documents, to trigger automated runbooks for operational tasks. Kinesis streams/firehose, for real-time data streaming and analytics. Real-world applications of Event Bridge. Let's consider some practical scenarios where Event Bridge shines. Automated security response. Problem: you want to be alerted and take action if a user accidentally creates a public S3 bucket, violating security policies. Solution: create an Event Bridge rule that detects the CreateBucket API call with specific configurations, like public read. This event then triggers a Lambda function that sends an SNS notification to your security team and potentially automatically modifies the bucket policy to make it private. Image processing workflow. Problem: when a user uploads a new image to your S3 bucket, you need to resize it into various formats and store the metadata in a database. Solution: an Event Bridge rule detects the object-created event in the S3 bucket. This triggers a Lambda function that performs the image resizing and metadata extraction, then stores the processed images back in S3 and writes the metadata to a DynamoDB table. Cost optimization through scheduling. Problem: you have development EC2 instances that are only needed during business hours to save costs. Solution: 2 Event Bridge rules using schedules. 1 to trigger a Lambda function to stop instances at 6 p.m. on weekdays, and another to start them at 8 a.m. on weekdays. Operational automation and self-healing. Problem: a critical service running on an EC2 instance repeatedly fails. You want to automatically attempt a restart. Solution: a CloudWatch alarm on a CPU utilization metric detects a consistent low CPU despite high load, indicating application freeze. The alarm triggers an Event Bridge rule that targets a Systems Manager automation document to attempt a graceful restart of the specific EC2 instance. Event Bridge elevates your cloud operations from manual intervention to intelligent automation. By embracing an event-driven mindset, you can build systems that are more resilient, more efficient, and capable of responding to changes in your environment with unparalleled speed. It bridges the gap between observation and action, transforming your monitoring infrastructure into a truly automated operational powerhouse. In the next chapter, we will explore some advanced CloudWatch features that further enhance your observability capabilities, taking you beyond the basics. Chapter 7, Expanding Your Vision, Advanced CloudWatch Features. We've covered the foundational elements of CloudWatch: metrics, logs, and events, as well as how to leverage them for alarms and dashboards. These core capabilities provide a robust framework for understanding and reacting to your cloud environment. However, CloudWatch offers a rich ecosystem of advanced features that can significantly enhance your observability, automate more intelligently, and provide a more holistic view of your applications. This chapter dives into some of these sophisticated tools. CloudWatch Synthetics, your robotic customers. While monitoring backend metrics like CPU utilization or database connections tells you a lot about your infrastructure's health, what about the end-user experience? Your servers might be fine, but if a third-party API is slow or a critical login button on your website breaks, your customers will suffer. CloudWatch Synthetics allows you to monitor your applications and endpoints from an outside-in, customer-centric perspective. It does this by creating canaries, configurable scripts that mimic user activity, running continuously or on a schedule from various AWS locations. Think of them as tiny robotic customers or automated web browsers that are constantly checking your application's pulse. What can canaries test? Availability. Is your website or API endpoint reachable? Latency. How long does it take for a page to load or an API call to return a response? Functionality. Can a user successfully complete a critical workflow, like logging in, adding an item to a cart, or completing a purchase? Broken links and resources. Are all images loading? Are JavaScript files accessible? SSO and authentication flows. Verify complex login sequences. Canaries leverage a headless Chrome browser for website monitoring or Node.js scripts for API monitoring. They generate metrics, e.g., success rate, duration, page load time, create detailed logs, and even capture screenshots and HTTP archive (HAR) files when failures occur, allowing for quick diagnosis of user-facing issues. Benefit: synthetics identify issues before your actual customers do. If a canary fails a test, it can trigger a CloudWatch alarm, alerting your team to a problem that might not be visible from backend metrics alone. CloudWatch anomaly detection. Smarter alerts with machine learning. Setting static thresholds for alarms can be challenging. What's normal CPU utilization? Is it always 60%, or does it fluctuate between 40% and 90% depending on the time of day or week? Static thresholds often lead to either alarm fatigue, too many false positives, or missed critical events, thresholds that are too high. CloudWatch anomaly detection helps solve this problem by leveraging machine learning. Instead of you defining a fixed threshold, anomaly detection automatically learns the typical patterns of your metrics and establishes a baseline. It considers factors like time of day of week, and seasonality. Once it understands the normal behavior, it generates an expected range or band around your metric. How it works. You enable anomaly detection for a specific CloudWatch metric. Over a period of time, it analyzes historical data, building a unique model for that metric. When the metric's value falls outside this dynamically adjusted band, it's flagged as an anomaly. You can then create CloudWatch alarms based on whether the metric goes above or below this anomaly detection band. Benefit: reduced false positives. Alarms only fire when something truly unusual happens, not just when a metric crosses a static line that might be normal for certain times. Early problem detection. Identify subtle deviations from normal behavior that might not trigger a static threshold, but could indicate an emerging issue. Dynamic thresholds. The model adapts to changes in your application's behavior over time, reducing the need for manual threshold adjustments. CloudWatch contributor insights, pinpointing the problem source. When an alarm triggers or you see a spike in a dashboard, your next question is often, who or what is responsible? Is it a specific user? A particular API endpoint? A rogue process? Manually sifting through logs or trying to correlate metrics can be time-consuming. CloudWatch Contributor Insights helps you quickly identify the top contributors to any CloudWatch logs or metric data. It continuously analyzes log events and metric data, generates charts that show the top-end contributors, and helps you identify the root cause of an issue faster. How it works. You create a Contributor Insights rule, specifying the log group or metric, and the fields or dimensions you want to analyze as contributors. For example, in your web server access logs, find the top IP addresses generating 5xx errors. In your database logs, find the top SQL queries causing high latency. For your Lambda function errors, identify the top function names contributing to the error count. The output is presented as charts that show the top contributors, their counts, and their relative impact, providing instant insight into who or what is contributing most to a particular behavior. Benefit: drastically reduces the time to identify the source of problems, bottlenecks, or usage patterns in your applications. Cross-account and cross-region observability, your global command post. For larger organizations, applications often span multiple OS accounts, e.g., development, production, test, security accounts, and multiple OS regions for disaster recovery or global reach. Managing monitoring data across these isolated boundaries can be a challenge. CloudWatch addresses this with features that facilitate cross-account and cross-region observability. You can designate a central monitoring account, a monitoring account that can see and act on data from multiple source accounts. This allows centralized dashboards. Create a single dashboard that pulls metrics and log data from applications residing in different accounts. Centralized alarms. Set up alarms in the monitoring account that watch metrics from source accounts. Unified troubleshooting. Operators can troubleshoot issues across entire application landscapes without switching accounts. Similar capabilities exist for consolidating data from different AWS regions. This provides a truly unified operational view, crucial for complex, globally distributed architectures. Expanding your horizon. These advanced features in CloudWatch empower you to move beyond basic health checks. Synthetics provide a critical user-centric perspective. Anomaly detection automates smarter alerting, contributor insights accelerates root cause analysis, and cross-account region capabilities unify your monitoring landscape. They allow you to be more proactive, intelligent, and efficient in how you manage your cloud operations. In the next chapter, we will expand this holistic vision even further by introducing other AWS services like X-Ray that seamlessly integrate with CloudWatch to offer comprehensive observability for modern, distributed applications. Chapter 8, The Holistic View, Observability with Integrated AWS Services. Throughout this book, we've progressively built our understanding of AWS CloudWatch, starting with its foundational pillars, metrics, logs, events, and advancing to powerful features like alarms, dashboards, synthetics, and anomaly detection. You now have a solid grasp of how to monitor the vital signs of your infrastructure and applications. However, modern cloud applications are rarely monolithic. They are often built as distributed systems, composed of many interconnected services, microservices, serverless functions, managed databases, message queues, and third-party APIs. Monitoring individual services might tell you if a specific component is healthy, but it won't necessarily tell you if the entire application is delivering a good user experience or where performance bottlenecks lie across multiple service calls. This is where true observability comes into its own. While traditional monitoring asks, "Is the system working?" observability goes deeper, asking, "Why is the system not working?" Or, "What parts of the system are causing this behavior?" It's about having enough insight into a system's internal state by examining its external outputs, metrics, logs, and a crucial third pillar, traces. CloudWatch, powerful as it is, doesn't achieve full observability in isolation. It integrates seamlessly with other specialized AWS services, allowing you to piece together the entire story of a request as it traverses your distributed architecture. This chapter will focus on how these integrations provide a comprehensive, holistic view. Beyond metrics and logs, the power of traces with AWS X-Ray. You have metrics, the gauges on your factory machines, and logs, the detailed operation manual entries. But what if you wanted to follow one specific product through the entire assembly line, seeing how long it spent at each station, identifying where it got stuck, or if it was handled improperly? This is what traces provide for your distributed applications. AWS X-Ray is a service that helps developers analyze and debug distributed applications, such as those built using microservices or serverless architectures. It provides a visual service map that shows you the connections between your services and resources. For each request that flows through your application, X-Ray collects data about its journey, including segments, information about the work done by individual services, e.g., a Lambda function, an EC2 instance, an API gateway stage. Subsegments, granular details within a service, like calls to external APIs, database queries, or I/O operations. Metadata, additional information about the request, such as user IDs, request headers, or error messages. By aggregating these segments and subsegments, X-Ray creates a trace, a comprehensive record of a request's entire path through your application. How X-Ray enhances observability. Service map. Visualize the entire flow of requests through your application, identifying which services are interacting and where bottlenecks or errors are occurring. Performance bottleneck identification. See the latency breakdown at each stage of a request, pinpointing specific services or database calls that are slowing things down. Error detection. Quickly isolate services that are generating errors. Troubleshooting distributed applications. Trace a single problematic request from its entry point to its final destination, seeing every service it touched and the time spent at each stage. Integration with CloudWatch. X-ray traces are automatically linked to relevant CloudWatch metrics and logs, allowing you to jump from a trace directly to the logs for a specific service call or to a dashboard showing its performance. Analogy: if your application is a journey, X-ray is like attaching a GPS tracker to every passenger. You can then visually see every turn they took, how long they stopped at each landmark, and exactly where they encountered a traffic jam or an unexpected detour. Holistic application, monitoring with CloudWatch application insights. Configuring monitoring for complex net and Java applications, especially those running on traditional EC2 instances or containers, can be a daunting task. You need to identify key metrics, configure log collection, and set up appropriate alarms for various components like web servers, databases, and message queues. CloudWatch Application Insights simplifies this. It's a managed service that automatically sets up monitoring for your net and Java applications running on services like EC2 auto-scaling, ECS, EKS, and even on-premises servers. It uses machine learning to detect common problems, identifies issues like memory leaks, high CPU utilization, thread contention, and slow database calls that signify application health issues, provide recommendations, offers actionable insights and suggestions for resolving detected problems, automate data collection, automatically configures relevant CloudWatch metrics, CloudWatch logs, and AWS X-ray traces for your application's components. Benefit: Application Insights reduces the manual effort of setting up comprehensive monitoring for your enterprise applications, automatically correlating data across different AWS resources and leveraging machine learning to highlight actual problems. Unified troubleshooting with CloudWatch Service Lens. With metrics, logs, and traces potentially spread across different CloudWatch interfaces and X-ray, it can still require some manual correlation to get the full picture during an incident. CloudWatch Service Lens brings all these pieces together. It provides a unified view of your application, combining metrics, logs, and traces from X-ray into a single, interactive service map. This feature is particularly powerful for understanding the end-to-end health and performance of distributed applications. How Service Lens delivers a unified view, integrated service map, visually represents your application's architecture and interconnections, much like X-ray, but with direct access to related metrics and logs. Health at a glance. The map visually indicates the health status of each service, showing clear indicators of errors or performance degradations. Drill-down capabilities. From the service map, you can click on any service to instantly view its key performance metrics, filter associated logs, or inspect individual X-ray traces for that service. This eliminates the need to switch between different console pages or services when troubleshooting. Centralized troubleshooting. It provides a single user interface where you can review, analyze, and gain insight into the health and performance of your applications. Analogy: Service Lens is the master control room for your entire factory. It shows you the overall layout, identifies which machines are acting up, and allows you to instantly zoom in on the affected machine, pulling up its diagnostic logs, performance graphs, and tracking the specific product that failed there. The observability mandate. In today's complex cloud environments, traditional monitoring is no longer sufficient. Achieving full observability is paramount. By integrating CloudWatch with purpose-built services like AWS X-ray, CloudWatch Application Insights, and CloudWatch Service Lens, you gain end-to-end visibility. Understand how customer requests flow through your entire distributed application, from the edge to the database. Faster MTTR, mean time to resolution. Quickly pinpoint the root cause of issues, whether it's within a specific service, a network call, or a database query. Proactive performance optimization. Identify potential bottlenecks and areas for improvement before they impact users. Confidence in production. Operate your applications with a higher degree of assurance, knowing you can quickly diagnose and address any operational challenges. This holistic approach moves beyond simply knowing if something is up. It gives you the full story, the intricate details, and the capability to truly understand and manage the health of your modern cloud applications. In the next chapter, we'll shift our focus to the operational aspects of CloudWatch itself, exploring best practices for cost, security, and overall smart operations. Chapter 9: Smart Operations, Cost, Security, and Best Practices for CloudWatch. So far, we've explored the extensive capabilities of CloudWatch, from collecting basic metrics to providing advanced observability. However, deploying and managing CloudWatch effectively isn't just about technical configuration. It also involves strategic considerations around cost, security, and adopting best practices to ensure your monitoring solution is efficient, secure, and truly serves your operational needs. This chapter will guide you through these critical aspects, helping you maximize the utility of CloudWatch while avoiding common pitfalls. Understanding CloudWatch costs. A pay-as-you-go model. Like most AWS services, CloudWatch operates on a pay-as-you-go model. This means you only pay for what you use, but it's essential to understand the primary cost drivers to manage your spending effectively. The key components that contribute to your CloudWatch bill include custom metrics. While AWS provides many standard metrics for free, you pay for every custom metric you publish. Costs vary based on the resolution, standard 1 minute versus high-resolution 1 second, and the number of metrics. Log ingestion, the amount of log data in GB you send to CloudWatch logs. Log storage, the amount of log data stored over time. Alarms, the number of alarms you create and their state, e.g. in OK state, you pay less than in alarm state. Synthetics canaries, the number of canary runs and the data processed during those runs. Contributor insights rules, the number of rules and the log data processed by them. Anomaly detection, enabling anomaly detection on metrics. X-ray traces, the number of traces ingested and scanned. Cost optimization strategies for CloudWatch. Managing your CloudWatch costs requires conscious effort. Configure log retention policies. CloudWatch log stores data indefinitely by default, which can become expensive. Adjust retention periods for your log groups based on your compliance, auditing, and troubleshooting needs. For instance, debugging logs might only need 7 to 30 days, while audit logs could require years. Optimize custom metric publication. Resolution. Only publish high-resolution, 1 second, custom metrics when real-time, granular insights are absolutely critical. Standard, 1 minute. Resolution is sufficient for most use cases and is significantly cheaper. Granularity. Be judicious about the number of dimensions you use for custom metrics. Each unique combination of dimensions creates a distinct metric, which adds to your cost. Frequency. Don't publish metrics more frequently than necessary. Dead metrics. Regularly review and delete custom metrics that are no longer being used or collected. Audit alarms. Remove any alarms that are no longer necessary or are constantly in an insufficient data state due to discontinued metrics. Ensure alarms are well configured to avoid excessive state changes and associated costs. Tune synthetics canaries. Adjust the frequency of canary runs. For critical paths, frequent checks are necessary, but for less critical ones, hourly or daily runs might suffice to reduce the number of runs. Review contributor insights and anomaly detection. Ensure these advanced features are enabled only on metrics or log groups where their intelligence provides genuine value. Security best practices with CloudWatch. CloudWatch collects sensitive operational data, making its security paramount. Principle of least privilege, IAM, restrict permissions. Grant only the necessary IAM permissions for users and roles interacting with CloudWatch. For example, a developer might need CloudWatch, put metric data to publish custom metrics, but not CloudWatch, delete dashboards. Specific resource permissions. Where possible, restrict permissions to specific CloudWatch resources, e.g., allow a role to access only logs within a specific log group. Use condition keys. Use IAM condition keys to limit actions further, e.g., only allow publishing metrics for a specific namespace. Encryption. Logs. CloudWatch Logs encrypts data at rest by default using AWS KMS encryption keys. You can also configure them to use your own customer-managed keys, CMKS, for additional control. Metrics. Metrics data is encrypted at rest and in transit. VPC flow logs for network security. While not directly a CloudWatch setting, enabling VPC flow logs, which stream to CloudWatch Logs, is a critical security best practice. They capture information about IP traffic going to and from network interfaces in your VPC, allowing you to diagnose overly permissive security group rules, monitor for denial of service attacks, detect unusual network behavior or unauthorized access attempts. Integrate with AWS CloudTrail. AWS CloudTrail records API calls made to your AWS services. CloudTrail logs can be delivered to CloudWatch Logs, enabling you to monitor for specific API activity, e.g., unauthorized changes to security groups or user creation. Create CloudWatch alarms on CloudTrail events to alert on potential security breaches or policy violations. Operational best practices for effective monitoring. Beyond cost and security, there are several general best practices to ensure CloudWatch is an effective operational tool for your team. Consistent naming conventions. Adopt a clear and consistent naming convention for metrics, log groups, alarms, and dashboards. This significantly improves discoverability and manageability, especially as your AWS environment grows. Example: app name, service name, metric name, log group, /app name /service name, alarm, app name, service name, metric threshold. Tagging resources. Use AWS resource tagging consistently across all your resources. CloudWatch supports filtering and group by operations based on resource tags, allowing you to easily view monitoring data for specific environments, e.g., environment, production, teams, team, billing, or applications. Avoid alarm fatigue. Meaningful thresholds. Continuously review and refine your alarm thresholds. Too many irrelevant alarms lead to your team ignoring vital ones. Actionable alerts. Ensure every alarm points to a clear problem and offers actionable information for resolution. Escalation paths. Define clear escalation paths for alarms, e.g., email notification for low severity, PagerDuty for high severity. Document your monitoring strategy. Document your key dashboards, alarm sensitivities, and the purpose of different log groups. This aids onboarding new team members and ensures consistency. Proactive versus reactive. While alarms are great for reactive alerts, combine them with proactive tools like synthetics and anomaly detection to catch issues before they escalate or affect end users. Automate responses. Leverage EventBridge to automate fixes or interventions where possible. This reduces manual toil and speeds up incident resolution. Regular reviews. Periodically review your CloudWatch setup. Are all dashboards still relevant? Are there any idle alarms? Are logs being retained too long? Is your architecture change reflected in your monitoring? CloudWatch is an incredibly powerful and flexible service, but its effectiveness lies not just in its features, but in how intelligently you deploy and manage it. By adhering to sound cost, security, and operational best practices, you can transform CloudWatch from a mere data collector into the true operational nervous system of your cloud environment, enabling your team to respond faster, operate more efficiently, and build more resilient applications. In our final chapter, we will bring all these concepts together through real-world case studies, demonstrating how CloudWatch empowers diverse applications and organizations. Chapter 10. From Theory to Practice. Real-world CloudWatch applications. Throughout this book, we've dissected AWS CloudWatch, understanding its fundamental components, metrics, logs, and events, and exploring its advanced features like alarms, dashboards, synthetics, anomaly detection, and its integration with services like X-Ray. We've also discussed critical operational considerations such as cost management, security, and best practices. Now, it's time to bring all these theoretical concepts and discrete functionalities together. This chapter will illustrate the power and versatility of CloudWatch through real-world case studies, demonstrating how organizations leverage its capabilities to build resilient, performant, and cost-effective applications in diverse scenarios. These examples will show how CloudWatch isn't just a collection of tools, it's an indispensable operational backbone, critical for successful cloud adoption and application management. Case Study 1. Monitoring a production e-commerce web application. Scenario: a mid-sized retail company operates a high-traffic e-commerce website on AWS, built using elastic load balancers, ELB, EC2 instances for web servers, and Amazon RDS for its database. The primary goal is to ensure high availability and a seamless customer experience, especially during peak sales events. CloudWatch application. Metrics for performance and availability, ELB metrics. CloudWatch monitors healthy host count, unhealthy host count, HTTP code target 5xx count, and target connection error count. Alarms are set on thresholds for these metrics to detect issues like unhealthy web servers or application errors originating from the load balancer. EC2 metrics. For web servers, CPU utilization, network in out, and status check failed metrics are closely watched. An alarm on CPU utilization exceeding 80% for multiple periods triggers an auto-scaling event to add more EC2 instances, ensuring the website can handle increased load. RDS metrics. Database performance is critical. Metrics like CPU utilization, database connections, read IOPS, write IOPS, and free storage space are monitored. An alarm on database connections approaching the maximum limit triggers an SNS notification to the database administrators to investigate potential connection leaks or scale up the database instance. Logs for troubleshooting and security. ELB access logs. These logs, streamed to CloudWatch logs, capture every request to the website. They are analyzed using CloudWatch logs insights to identify popular pages, top IP addresses originating requests, and the distribution of HTTP status codes, e.g., a sudden increase in 404 not found or 500 internal server error responses. Application logs. Custom application logs, e.g., for user login attempts, shopping cart transactions, payment failures, are sent to CloudWatch logs. Metric filters are created to extract key events like payment failed or user login error, converting them into metrics that can trigger alarms. VPC flow logs. Network flow logs are sent to CloudWatch logs. They are used by the security team to identify unusual network traffic patterns, potential unauthorized access, or misconfigured security groups. Dashboards for operational oversight. A primary CloudWatch dashboard serves as the e-commerce command center. It includes line graphs for ELB latency, EC2 CPU, and RDS connections. Alarm status widgets for critical alarms provide quick visual cues. A log insights widget displays the most frequent application errors in real time, enabling rapid troubleshooting during incidents. Synthetics for customer experience. CloudWatch synthetics canaries are set up to simulate a customer journey, browsing products, adding to cart, and attempting a checkout. These run every 5 minutes from multiple Oz regions. If a canary fails, e.g., cannot add to cart, or takes too long, an alarm immediately notifies the operations team, preventing widespread customer impact. Outcome: by comprehensive use of CloudWatch, the e-commerce company transformed its monitoring. They now proactively scale resources, identify performance bottlenecks before they impact sales, and rapidly troubleshoot issues using detailed logs, effectively ensuring high availability and a smooth customer experience. Case Study 2. Observing a serverless microservices platform. Scenario: a fintech startup built its core API backend using a serverless architecture. API gateway, AWS Lambda functions, and Amazon DynamoDB. The platform handles millions of transactions daily, and understanding transaction flow, latency, and costs is paramount. CloudWatch application. Comprehensive metrics. API gateway. Monitors latency, 4xx error, and 5xx error counts for all API endpoints. Lambda tracks invocations, duration, errors, and throttles for individual Lambda functions. DynamoDB monitors consumed read capacity units, consumed write capacity units, throttled requests, and latency for critical tables. CloudWatch dashboards are configured to show aggregate views of these metrics and to drill down into specific microservices. Distributed tracing with AWS X-Ray. X-Ray is enabled for API gateway and Lambda functions. When an API request comes in, X-Ray traces its entire journey, from API gateway, through one or more Lambda functions, to DynamoDB reads writes, and any calls to external services. Service map. The X-Ray service map provides a visual representation of how different microservices interact, highlighting which component is causing latency or errors for specific transactions. Trace analysis. When a customer reports a slow transaction, the operations team can pull up that specific trace in X-Ray, see exactly which Lambda function or DynamoDB operation caused the delay, and then link to relevant CloudWatch logs for more detail. Log analysis for granularity. All Lambda function logs are streamed to CloudWatch logs. Logs insights queries are heavily used to analyze success failure rates by transaction type, identify common error messages and their frequency, calculate the average duration for specific code paths within functions, debug individual invocation issues, event-driven automation with EventBridge. Custom events are published from the microservices to EventBridge for key business actions, e.g., transaction approved, fraud detected. EventBridge rules then trigger Lambda functions to update downstream systems, send notifications to customers, or initiate auditing workflows, all without direct service-to-service calls. Scheduled events trigger daily reconciliations and reporting through Lambda functions. Application Insights for Health. CloudWatch Application Insights is configured to monitor the core Lambda functions and DynamoDB tables. It automatically detects issues like memory leaks or high resource consumption patterns, providing smart alerts and recommendations. Outcome: the fintech startup achieves comprehensive observability over its complex serverless platform. They can precisely pinpoint performance bottlenecks, quickly identify root causes of transaction failures, automate critical business processes, and proactively manage their DynamoDB capacity, ensuring high performance and regulatory compliance. Case Study 3. Cost Optimization and Security with CloudWatch. Scenario: a large enterprise manages hundreds of AWS accounts and thousands of resources. Controlling spiraling costs and maintaining a strong security posture are daily challenges. CloudWatch Application. Cost Discovery with Metrics. CloudWatch alarms are set on general AWS usage metrics for services, e.g., estimated charges for an account or storage bytes for S3 buckets. Custom metrics are published for underutilized resources, identified by tools like AWS Cost Explorer, e.g., EC2 instances with less than 5% CPU utilization for the past week. An alarm on this custom metric triggers an SNS notification to the responsible team to review and potentially shut down idle instances. Security monitoring with logs and events. CloudTrail integration. CloudTrail logs, recording all AWS API activity, are streamed to CloudWatch logs. Metric filters are created to detect suspicious activities, unauthorized API calls, changes to IAM policies, deletions of critical security groups. Alarms on these metric filters send immediate alerts to the Security Operations Center, SOC. VPC flow logs. VPC flow logs are extensively used in CloudWatch logs insights to identify traffic to from known malicious IP addresses, unusual outbound network connections from internal servers, high volumes of denied traffic, indicating potential scanning or misconfigurations. EventBridge for remediation. An EventBridge rule is set up to detect events like an S3 bucket being made publicly accessible. This event triggers a Lambda function that automatically reverts the bucket permissions and notifies the security team. Centralized monitoring for auditing and compliance. Cross-account observability is implemented. All log data, CloudTrail, VPC flow logs, application logs, from various accounts is aggregated into a central security and logging accounts CloudWatch logs. Dashboards in the central account provide a consolidated view of security events and compliance posture across the entire organization. CloudWatch logs insights queries are regularly run for audit reports, ensuring adherence to internal policies and external regulations. Outcome: The enterprise gains unprecedented visibility into its OS costs and security posture. They can quickly identify and remediate idle resources, detect and respond to security threats in near real time, and generate comprehensive audit reports, leading to significant cost savings and a strengthened security landscape. CloudWatch, the essential cloud operating system. These case studies underscore a vital truth. In the cloud, CloudWatch isn't merely an optional add-on. It's an integral component of your operational strategy. It empowers you to know your system, understand the performance, health, and behavior of every part of your complex cloud environment. React intelligently. Get precise alerts when things go wrong and automate responses to maintain stability. Optimize continuously. Identify areas for performance improvements, cost savings, and security enhancements. Build resilient applications. Design systems that are self-aware and can adapt to changing conditions. The cloud constantly evolves, and with it, the art of observation. CloudWatch is at the forefront of this evolution, continuously adding new features and integrations. For anyone building, managing, or operating applications on AWS, mastering CloudWatch is not just a skill. It's a necessity for success in the cloud era. It transforms the abstract, invisible nature of the cloud into a transparent, manageable, and highly observable operational landscape.